Steve, is this yours? All right, cool.
Right. What have I got to connect to then?
I'm assuming that guy.
Well, that's, yeah.
Is it HDMI? You got an HDMI adapter?
No, this is
Oh,
VGA.
VGA.
Ah, there's VGA.
Excellent.
No, that's not going to work. That should be fine. Go on, machine, wake up. What are you doing? Aha!
So the question is really,
It's clearly already noticed it's connected to something. That's saying source HDMI.
we got down here.
Right, this is connected to this. Right, cool. Ah! Hang on a second. One sec. That'll work. It's okay. I found a converter box. So I'm thinking. Hey! It's okay. It's okay. I have disconnected it intentionally for a second while I ran through the slide deck. Just give me a moment. Computer was right. It was happy before. See? All right, are we all sitting comfortably? No. Well, tough. So this talk is called Build Management with a Dash of Prolog. I will make the microphone feed back if I do that. This has happened before. However, okay, so I am hoping that a reasonable chunk of you already know who I am, but I always get asked about this afterwards, so I am MST. I am honestly an accidental Perl hacker. Late 2001, I was hired to an ISP to write Visual Basic applications for the search engineering department, which was an experience, let us say. 4 days in, there was a backup accident, largely because the guy responsible for the backups was unbelievably stoned. 2001 ISPs. Those of us who were in the industry then will not be surprised at all, I'm sure. And we were doing 2000-style CGI scripting. I mean, the only module we used was DBI. Didn't even use CGI.pm, no. Had our own stanza for query parameter parsing that we copied and pasted to the top of every script. It was December 2000. That was actually relatively high-tech at that point. But a lot of what I worked on there was systems automation and account provisioning stuff, building out Unix users on the mail host, entries in the LDAP tree, creating directories, whatever. And doing operations work in the sense of if the person on call couldn't figure out why everything was broken, he'd call my boss, who was the bastard network administrator from hell. I loved the man dearly. And if my boss was still stuck and needed some company trying to figure it out, he'd call me. Which was, on the whole, actually quite good fun. Working at 3 a.m. with the only other person in the company I considered to be actually good, you know, and nobody interrupting us was kind of pleasant, apart from the 3 a.m. part. But anyway, so I developed something of an obsession with systems automation. And the whole idea of being able to do round-trip testing of stuff so you not only try and provision something, but verify that you've provisioned it correctly. I also inevitably did quite a lot of mid-outage duct taping. Possibly my favorite one being, actually no, there's too many stories, catch me over a beer. And then a few years later, I got kind of distracted when Mark Keating and I accidentally started a company. And we ended up mostly doing consultancy around web and database development. The irony here being that I got into doing web and database libraries because I wanted the web development to take less time so I could get back to the systems automation. Didn't quite work out that way. So yeah, we are at this point effectively quite comfortable consulting on anything that's CPAN stack, but we also tend to do systems work. One of the first things I end up doing for most customers is redesigning their deployment setup so it doesn't suck as much. So, I mean, these apps are fairly large scale. Once you've got Catalyst, DBIX class, and a bunch of other things, a dependency chain of 300-400 CPAN modules is not actually a surprise. And frankly, once you've got the deployment fixed, it's still a huge improvement over writing all that rubbish yourself. But does tend to be a little bit of a problem sometimes when things go wrong. Going back to the system side, okay, a user might have a home directory for them to FTP up to, an LDAP entry that controls authentication, and a virtual host. This is classic shared hosting stuff. But equally, a program might need a particular set of CPAN modules. And it occurred to me over the years that these are actually sort of the same class of problem, and yet we have configuration management and dependency management tools, and never the twain shall meet, or at least one drives the other. So to try and get a holistic model, you need to be able to describe the whole system. And more importantly, one of the things that's always driven me insane is, if I'm looking at, say, a Puppet config or a CPAN file or whatever, I can see what, but the reason why this stuff is there usually only exists on a wiki page, that was last updated 3 years ago by somebody who's now left. Right? So I wanted to come up with a system where you actually baked at least some of the Y into the configuration so it was right in front of you. So I decided to follow a metaphor of sort of mathematical equation solving, kind of, sort of. I did a pure maths degree a long time ago, so, you know, but fundamentally I've forgotten more mathematics than most people have ever learned, but I don't consider myself a mathematician anymore. But so the idea is you want to say there exists some X such that X is a server which has the dependency for your application installed. And so that's a pure test, yeah? That's saying, is the server set up properly? And you're effectively solving for free variables, so you can get, here are the different servers that are set up like this. And that's great. But the thing is, what you actually want to do is solve for suitable realities, not necessarily the current reality. Because if you've got no servers with it provisioned, you need to be able to figure out how to provision it. So you talk about there exists a world in which X exists such that. More importantly, you say given a world W, there exists a possible world W dash such that in that world, everything would be provisioned, and then you try and make the current world into the world where everything's already done. Lol. For those of you watching on the live stream, somebody just tried to convince me that's what Puppet does.
I didn't try to.
Well, you certainly weren't trying very hard. Anyway. So you're looking for a value for X. The thing is, so if you've not already got it set up, what you need to return is not false, but false but. And then in this counterfactual world, this would be true. And then you need to return a list of operations that will create that world from the current one. So you end up with a concept of values, which are your actual free variable bindings, and actions, which are the things that you get there. So, you know, an example of an action would be installing a package. And then you can ask it to run the actions. Crucial thing here is it has to be able to give you the actions first, because I will never forgive any tool that does not have the equivalent of make minus n. Dry runability is really important. I want to know if I've screwed this up before I go to the trouble of running the entire thing on a VM. Also, I want to be able to repeat things. So the idea is, because your solution, okay, it contains actions to execute, but the solution itself is effectively the result of a pure function, which means you can always reproduce that result, and you can see exactly how it got to where it was going. And plus, because once it's actually done it, it returns, this is true, no actions. It's idempotent, so you can keep rerunning it. So in order to support this, I built a thing called DX, which is basically a prolog-inspired equation solver. Prolog-inspired because prolog has no concept of side effects. The only way you get side effects is via what's known as extra logical predicates. For those of you who know Haskell, what that basically means is the only I.O. in prolog is unsafe perform I.O. Not quite what I wanted. Unsafe and root do not go together unless you like being woken up in the middle of the night. But it's still a rule-based system. So you write a rule for a web server is installed on some host X. If it's a server, you have some web server W, you have a package of that available, and the package is installed. Now, because the system operates on pure logic, you have to bind it to the outside world somehow. So you have a thing called observers. An observer is basically, it's kind of the equivalent of a tied hash. So when you look up a value in it, it goes and queries the state of the outside world and returns it in a way the solver can understand. And I'm hoping that's a simple enough example for does a file exist? Well, is it a directory in this case? And then you have actions, Actions must be able to dry run. They have to be able to say, this is what I expect the world to be like after running without running. One of the key reasons I did it this way is, I don't know if you see any tool, look at Ansible. Ansible does have a dry run option, but it only works if the authors of each individual module has implemented dry run. Because it's optional, people go, oh, well, it works now, I'll get round to the dry run later. You know, we all know that we all do that, right? So having a system where it will not work at all unless you implement dry run is basically a defense against our own laziness. So if you say for something like, this path as a directory equals true, it can either go, yes, it already is, that's great, or it can issue an action that makes the directory and says, forget that value. So you solve with the dry run results, get a complete set, run the actions, and then it resolves, and at this point, it hasn't recorded is dir is true, it's recorded is dir is unknown, which means the observer ends up going and rechecking it, which means it always actually verifies that it's got the right results, which isn't so important for there, but if you're running, say, a vendor install script, do you really believe that when the vendor install script exits 0, it's worked? So the system doesn't trust itself for good reason, especially since the system was written by programmers. So I first talked about this at Flush UK 2014, which was basically talking about ideas. Flush UK is they used to be users group. They rebranded because oh, I don't even know. I avoid being involved in conference organization because that involves being awake in the morning. And I had a running sort of prototype, which by the end of my talk, I immediately realized I needed to rewrite completely. Because that always happens, right? By FOSDEM this year, I was doing a bit better. I had an actual prototype of the solver that was doing basically what I wanted. But of course, naturally, when you do conference-driven development, something... So I ended up having to give a talk at FOSDEM that was saying, I have this amazing thing, but it isn't... Fortunately for me... yeah. But anyway, so the thing that I'm attempting to build on top of it first is called CDX. The reason CDX is going to be a build system. The reason for this is, if I am going to claim this is a good way to write deployment systems, it has to be able to deploy itself. Yeah? If it can't do that, so CDX nominally stands for CPAN via DX, but realistically, what it actually stands for is CDX run. It's Perl stuff. We have to have puns, right? So yeah, it's going to be a Perl and CPAN build system that I'll then expand out into other languages later. Unlike most of the stuff that we're currently using, it goes from a source to a depot, then to installation, rather than straight to installation. So you get the question, what's a depot? Well, you start off with a tarball, and then you have an extra directory for it with a build indexed by UUID, because reproducible builds are really hard, whereas allocating a UUID is really easy. And plus a JSON file containing some information. So the top level input is a list of requirements, and then your resulting output is a list of builds to install. Or, if you don't already have binary builds, it's a list of potential builds, bearing in mind we can say false, but yes, now I've got full. And yeah, it sounds easy so far, right? Yeah. As a number of people in this room were very well aware, the toolchain hates us all. First thing, my meta. Meta.json tells you approximately what the dependencies are probably going to be. You don't have a normative set until you have a myMeta file. And you don't have a myMeta file until you've configured the distribution, so you can't reliably predict things in advance. So dry run has to simulate it. It'll probably be what meta.json says, but don't count on it. So you end up basically, your dry run pulls the cpandis meta requirements, runs with those, solves everything else out, and it can come back. Obviously, the resolve and recheck stuff means once you've got myMeta, it can come back later and get it properly. Configuration has static dependencies, so that's relatively easy. So, you basically untar the thing, run makefile.pl, tar it back up, record it under a UUID, resolve the real dependencies from myMeta, and now you can do your make test, make install. And that gives you what I refer to as a completion, which is basically a build directory that everything's been done on. I'm snapshotting everything as I go along, because if something fails to build, I want to be able to go back and untar the one that failed and look. I remember some years ago at OSCON talking to some active state people, and one of their biggest hatreds in life was when something didn't build on the PPM build farm, having to rerun that entire build from scratch to figure out what went wrong. And I swore I was not letting that happen to me, because I really don't have the patience for it. So what it then does is does the make install into a per dist local lib, which it can tar up, at which point building your local/directory a la carte is just tar xzf on each of the builds you've selected. So, okay, now we have real dependencies. Resolve, run the next build, repeat until you've got everything. Once you've got a full set of actual builds, you can run your untar. So, yeah, great. Yeah. So, configuration and completion are separate steps, which means they run in a separate temp directory each time. Turns out, nobody considered the possibility that you might want to move the build directory around between makefile.pl time and make time. Module build, the bane of my existence when it comes to toolchain stuff, writes absolute paths during configure, and therefore attempts to build a directory that no longer exists. Apparently noticing its current working directory is beyond it. I suspect the module build team are considering whether to fix this, but I want to be able to support building on older versions anyway. What?
What module build team?
And that was somebody yelling, what module build team from the audience? Okay, let me put it another way. The poor bastards keeping module build on life support until we can finally convince CPAN authors to stop using the horrible pile of tentacles and Cthulhu that it is. So what you have to do is for build time, you give it a -- base dir argument and basically forcibly override its own stupidity, and then it does the right thing. Then we have the thing of the final install target is yet another directory. So we don't know what that is at configure time. So for module build and module build tiny, you just do build install with an install base of that directory. However, you try and do that with MakeMaker. Oh yeah, I broke everything doing this. So you do make install base equals, and MakeMaker proceeds to install something completely random and fail because MakeMaker selects the old school prefix style or the modern install base style at configure time and writes out a makefile specialized to that approach. So you do this. Feed it a fake directory, at which point it writes the correct sort of makefile, at which point there's actually an install base variable in the makefile to override, and then it works. Module build tiny, by the way, actually did not screw me over at all in this process, apart from the fact that you can't run build test until you've run build because it doesn't do action cascading. However, I'm not sure if I actually consider that a bug, because realistically, I'm going to want to separate the build and test phases later anyway, so I don't actually care about that. So yeah, now we can actually build stuff. Next problem. So, the unit of deployment for CPAN stuff is a distribution table. The unit of dependency resolution is a package name. Which means my original algorithm for this resolved by distribution. And then I realized that that can go horribly wrong, because you can end up with one package resolving to one tarball and a different package resolving to a different one. And since packages can move around between distributions, and there's no actual true concept of a distribution name, the only uniqueness on CPAN is the complete path, including the author name and the name and version. So you can't do uniqueness across distributions. You have to do it across packages. So you have to track packages to dists. So, one second. So your build set that you're trying to set up, you say, for each thing in its provides metadata, we need to make sure that this build is scheduled as providing that package name. Now, remember, this is a solver system. So if there's nothing already providing it, it solves that by setting the value. If we've already resolved this thing, then it's a no-op. If we've already resolved something else, it goes, nope, that's not going to work. But because we're prolog style, it then backtracks to the previous choice and tries a different option, which means that eventually it will come out with a full consistent set. Unless it goes into an infinite loop, but that would be called a bug. And this is really nice, because that means I'll be able to use the same approach for X breaks to do conflict detection. So I don't know if you're familiar. If you upgrade Moose as part of a deployment, you then need to run Moose outdated, which gives you a list of Moose extensions that also need to be upgraded, because otherwise they're not going to work on your new Moose. I should be able to automate that with basically, the solver will just do it. It's one of those things, you spend a couple of years getting the right algorithm, then stuff starts falling out fairly easily. For toolchain values of easily, of course, but. So, next hilarity, dual life modules. We don't actually have complete uniqueness. We have uniqueness across the CPAN tarballs, but those may be overlaying the underlying Perl one. So what you have to do is make it so it can stack. So what you have is, remember that this is a decision engine, so it keeps trying options. So in this case, we have a rule with two different bodies. The first body only activates if the build that's been selected is the Perl, at which point it checks that we don't have an entry for it of a CPAN dist. And then the second body says if it isn't a Perl, then we go and do the provides map thing. So one or other of those will succeed. So at this point, we're getting closer. So you can have a top-level rule that goes, what are the builds for this requirement set? So a memberat is basically an each, except for the fact that Perl's each is dangerous and should never be used in production code, whereas this one actually works. And then you ask it to solve for the build set providing the module with the version requirement. Then it looks up a possible build, which will either be an existing one we've already built, or a potential build based on the pause index or whatever else. That's pluggable, and you can change the order underlying it. Checks the version matches. Checks the provides map, doesn't have any clashes, and then goes and recurses into its dependencies and makes sure all of those are satisfied. So having done that, out in Perl space, you can say, build resolver, please give me a solution for these dependencies. And then, at this point, I have a small amount of code pulling the results out and printing it out. And then remember, we always support -n, so add that on. And if on my development box I run that with a -n, it gives me a list of builds, of tarballs, and the UUIDs of the projected builds for it. So it's saying that's what I think I'm going to install. Bear in mind that my meta differing from meta can change that later. And then to actually do it, you call materialize on it, at which point the solver goes run first action, resolve, run first action, resolve, and keeps going until it has no actions, and then it's got something to untar. So if you run it without the -n, it goes through and builds all of those, stashes the resulting installation tarballs in the depot tree, and then does an untar, so you end up with a full tree created. The nice thing about this is, because a binary build versus a binary build I am going to create are equal things in this system, if you rerun it now, having already built it, it just does an untar, at which point you go from 0 to a complete local lib in a couple of seconds, because there's a small amount of Perl grinding, and then tar_xzf is pretty fast. So I still have a few bugs to shake out, notably one that is an infinite loop. These things happen. But I am quite serious at this point that I should be shipping within the next few weeks. Of course, now I've said that, tomorrow I'm going to try and do something and find another world-breaking problem, but, you know, you've got to risk jinxing yourself at some point. And so this is where I blog random rubbish about Perl. Watch this space, because I will be posting on there when I finally get this shipped. And thank you very much. And since apparently I just went through 160 slides in a little over half an hour, we appear to have time for questions. Anybody? Tell us about Puppet. Oh, thank you. You're too kind. No, I don't object to Puppet. I was kicking around on the infrastructures mailing list when Luke Caney's first started working on Puppet. And I remember he'd actually been a Perl hacker previously, and wrote Puppet in Ruby because he wanted better OO, which I find ironic because in the era of Moo and Moose, the reason I hate writing Ruby is that the OO is terrible compared to ours. Every time I try and write Ruby, around the third time I have to write my own constructor, I throw my toys out the pram and go back to Perl. Though if you are suffering Ruby, there is a gem on GitHub called MooseX where they have actually ported has, and it gives you accessor and constructor generation. In Python, there is a project called Elk that is attempting to do the same thing. Hopefully, at some point, somebody will do the same thing for JavaScript, because that's a language I actually care about writing stuff in. Juice was a part of the full Moose meta model. It's not really a JavaScript native approach. What I would like to see is Moose/Moose readapted for JavaScript rather than blindly ported. Because, you know, prototype-based OO is not class-based OO. As anybody who's written JavaScript will attest, the worst thing in JavaScript is when people try and write class-based OO. And no, just don't do that. But no, the thing about Puppet is you declare a desired system state, and then it goes and smashes the system into that state via brute force. Which is fine, except what that tends to result in is people don't run Puppet on their development servers, because otherwise you edit the host file for a temporary test, and Puppet comes along and smashes it into the standard state, and now your tests start breaking. Also, speaking as somebody who spent a while getting called at 3 a.m., if you are tired and forget to stop the Puppet daemon while you're duct taping production back together, Puppet will gleefully break it again for you. Which is why I want things like dry run and the ability to be relatively intelligent. My intention when I get onto config files is to basically go, if the current content of the config file is a previous version we've installed, overwrite it. If not, well, a perfectly valid action is sending an email to file an RT ticket and then somebody can go and check. I would like systems tools that think that I own the systems, not them. Oh, what?
Tell us about the infinite loop.
So that was tell us about the infinite loop. Yes, Mr. Heckler. First, I need to tell you about the infinite loop. No, the is test more and scalar util both depend on if something else. So the question is, can it be used to build RPMs? And the answer is, I am building tarballs. One of the reasons I'm building tarballs, other than the fact of that's a nice universal thing that works with tools that don't require root, is that I have plans later on to then write a bunch of code that instead of untarring them into a local lib, I want to fix the remaining 5 when everything's going well. But also remember those times. Having separated out the test phase, what I can do is install everything that's on the requires list, then try and build everything on the recommends list, then rerun the test phase to double check that now it's got optional dependencies, everything passes. Which is obviously going to be a little more work than just merging the deps into the hash ref, but I think will produce a much nicer user experience. Also, I want to be able to record where a given dependency came from, because personally, if I have a CPAN recent enough that it turns recommends on by default, I get all sorts of confused when things I never expected to install get installed, because it's going, oh yeah, this has some recommends, let's just smash those in as well. The problem I have with that is that's then not reproducible, because you've got a bunch of things in your deployment that if you did the build a different way wouldn't be there. And I'm not sure I'm entirely happy with that. From my point of view, I think really what you want is something where, for a production deployment, recommends actually gives you, here's a list of recommendations, do you want to try and build these? And once it's built them, says, do you want me to add these to your CPAN file so they become part of your dependency tree, so that for the production build, you can do a straight requires build and still get the right results. And I'm not sure any of those are exactly the right thing, but I think that basically, well, one of the problems I have here is, because it's a lot more flexible than the resolvers built into existing CPAN clients, there's a huge number of different things that it can possibly do. So, and as is traditional with there's more than one way to do it, most of them are probably going to turn out to be a terrible idea. Once I have the basic thing shipped, my intention is to basically add options to try a few of the alternatives, and then we can actually play with them and see which ones are a good idea, and then I'll bake those in as defaults. Yeah, that was a really long way to say not sure yet, but I have some ideas, but... And since the 5-minute warning went about 2 minutes ago, does anybody have one more question? Awesome, that means I can go and get more coffee. Thank you very much. If you have other questions, anytime during the conference, because, you know, fundamentally your ideas about what you would like something like this to do are of interest to me, because even if I don't think they're a good idea, I'm quite interested in making it so that you could at least write a plugin to make that idea work. And other than that, thank you very much for listening, and keep an eye on my blog. Hopefully I will manage to ship this soon. Cheers!